Hello everyone. This video is on section 10.2, part 1, titled Graphing Exponential Functions. Alright, so in this video, I'm going to be going over a version of the Knewton Alta assignment for section 10.2, part 1. Please understand that the questions I see in this version may not be the same questions that you see when you do the assignment on your own. But the objectives are the same, the types of questions should be similar, so I'm hoping that watching me go over a few here help you in some way when working on the assignment on your own. Okay, so here's the assignment page. Now you will not see the words preview of. You'll only see the title of the assignment. Then you have your mastery bar telling you how far along you've gotten in the assignment. And beneath that, the objectives. Now it looks like there are only 2 objectives here. And beneath each current objective, you'll see a question related to that objective. And at the bottom of every question, there should be a feedback button, which you can send feedback to Knewton. You will not see the instructor cheat button, right? That will not be there. But you will see a more instruction button. Right, and you can click on this and see further reading material, maybe some videos related to the objective at hand, and hopefully those help. Okay, so our first objective here for this question, this first question I'm seeing, is evaluate an exponential function with base e and understand the natural base. Alright, so I gotta talk about a few things first before we get into this question here. Alright, so I'm going to do a little discussion first on exponential functions. Alright. Now it's in the name, exponential. The word exponent is the root word there. So the inputs, right, the values you plug in, they're going to go into some expression in an exponent, right, into a power. So the most basic exponential functions look like this. Y equals, or f of x, remember the function notation, equals, and then some number, which I'll call b for base, right, to the x power. This is the most basic version of an exponential function, right, where b is a constant, right? B is called the base, right? The base, b is constant. And also, just to make things easy for us, right, for this introduction, we're going to have b be a number that is positive. Right. So we're not going to be looking at exponential functions with a negative base. Right. Okay. So what I want to do is just take a look at some examples. I mean, graphing these is no different than graphing any other function. Notice that the variable, the input, is x here. I'm calling it x. The input is in the exponent of this base b. Thus the name, why they give it the name an exponential function. So a very simple, I'm going to go over some very basic examples here. How about f of x, or y equals 2 to the x. I'll start off with a pretty easy base, right? 2 to the x power. Right? 2 to the x power. Right, so what I'm going to do is, just like with any other function, I'm going to make a little chart, x and the output f of x. Now you have to remember certain things about exponents to make these easy, right? And I'll plug in some values here. I'll plug in 3 for x, I'll plug in 2, I'll plug in 1, 0, -1, -2, and -3. Alright, so remember this is the input x that's going in the exponent. Right, the output would be 2 to the third power, 2 to the third power, which is 8. Right, 2 times 2 times 2. When x is 2, the output is 2 to the second, 2 squared, which is 4. When x is 1, the output is 2 to the first, which is just 2. Now, hopefully you remember this from some properties of exponents in the past. When I plug in 0, 2 to the 0 power, remember, is 1. Okay. And look at the pattern here. Every time I decrease the input by 1, the output gets cut in half. Right? 8 divided by 2 is 4, divided by 2 is 2, divided by 2 is 1. And that continues. That pattern continues. Remember, when you plug in a negative number, hopefully this rings a bell, 2 to the negative first power is just 1 over 2 to the first power. Remember properties of exponents, right? Raising a number to a negative power is just the reciprocal of the positive power. So we get 1/2 when I plug in -1. And 2 to the -2 power, right, replacing x with -2, is 1 over 2 to the +2, or 1 over 4. Right, so you see that 2 to the -2 is just the reciprocal of 2 to the +2. Right? And 2 to the -3 power would be the reciprocal of 2 to the +3, so 1 over 8, 1/8. But always positive. Notice my outputs here are always positive numbers. And then I go to graph. Now I'll make a rough sketch by hand first. X-axis, y-axis. I'll mark off 1, 2, 3, and -1, -2, -3. And then here's 1, 2, 4, and 8. Right. And I'll plot these points. Right. 1 point was the ordered pair 3, 8, right? Input 3, output 8. So 3, 8. So something like this. Right? There's a point on my graph. 2, 4, right? Input 2, output 4. 1, 2, right? Input 1, output 2. 0, 1. And -1, 1/2. Right, so here's a half here. And then -2, 1/4. So half of that. At input -2, output 1/4. Then -3, 1/8. -3, now 1/8 is half of 1/4. That'd be like here. All right, and you see the curve forming? Be looking like this. Draw a nice smooth curve through all these points. Right, don't connect them with straight lines. Right, there's not straight. Now it's going to continue upward forever. I hope you understand that, right? When I plug in 4, I'd get 4. Then 2 to the 4th is 16. 5, 32 would be the output. 2 to the 5th is 32. Right, the larger my input gets, the larger the output. It's going left. That's a little weird, right? It'll keep going down, but never be negative. Right? If I plugged in -4, I'd get 1/16 as the output, still positive. If I plug in -5, I'd get 1/32 as an output, still positive. All right, so this is so we have what's called a horizontal asymptote. The graph approaches the x-axis, but never actually touches the x-axis, right? In fact, I'm going to put in like a little make the x-axis into like a dashed line here. Right, and they'd call this thing a horizontal asymptote. Right, it's a horizontal line that the graph gets closer and closer to, but never actually hits. Asymptote. Right, so, and that's, y equals 0, the x-axis here. Y equals 0. So yeah, horizontal line that the graph is getting closer to, but never actually touches, never actually hits. And then it's going off that way. It's increasing as you move from left to right. The graph is going up forever. All right, so some properties here. So again, 1, it's got this horizontal asymptote. 2, it's an increasing function. They would call it an increasing function. That just means as the input increases, the output also increases. As you go from left to right, the function is increasing, going up forever. The domain is all real numbers. Right, and I'm putting that in interval notation from negative infinity to infinity, right? You can plug in anything you want for x. Right? I can plug in any x value I wish and I'll get some output. Right? It's never undefined. The range, however, is not all real numbers. Right? The range is only positive numbers. See, the y values that are being used are everything above 0, but not 0 itself, and there are no negative outputs either. So the range is values from 0 to infinity, but not including 0, right? That's why I got parentheses on 0. Okay. So yeah, just some properties of your basic exponential function, y equals 2 to the x. And if you'd like a much nicer looking picture of this, let me actually pull up that desmos.com website. All right, this is a free online graphing calculator, desmos.com. And I'm just going to put in, y equals 2 to the x power. All right, and go back to the main screen here. And you see the green exponential function. There's the point 0, 1. Right, you have the point 1, 2, right? The point 1, 2, the point 2, 4, right? Negative 1, 1/2, right? Negative 1, 1/2, or 0.5 there. Negative 2, 1/4, right? 0.25, and so on. And I'll put in the horizontal asymptote as well, just y equals 0, right? Which is the purple x-axis now. And I'll make that like a dotted line. Right, make it a dotted line instead of an actual line. And you can see, if I zoom in here, you can go as close, that green graph, right? The green graph is the exponential function, y equals 2 to the x. And you can see, no matter how far to the left I go, no matter how small I make my inputs, see the output is always positive. It's approaching the purple dotted line, it's approaching the x-axis, but never actually hitting the x-axis. See, I know it looks like it hits the x-axis here, but if you zoom in, as get closer and closer and closer, you'll eventually see that the green graph is not actually hitting the x-axis. Right. Okay. All right. So back to the assignment here. Now, actually, I want to go back to the discussion, right, the lecture. All right. So there's one example. Now this had a base bigger than 1. See, when the base was 2, the graph was increasing. Just the basic 2 to the x. The graph was increasing. Well, what if the base was less than 1? Right? We're still working with positive bases here. So what if the base were less than 1? So one more example. What if I had f of x equals, instead of 2 to the x, how about 1/2 to the x? Right? So this time the base is less than 1, but still positive. Alright, so same deal, I'm going to make a little chart, and we'll plot some points, a chart of inputs and outputs, x and then f of x. And I'll use the same values for my inputs, 3, 2, 1, 0, -1, -2, and -3. Now, what's 1/2 to the third power? That'd be a half times a half times a half. That would be 1/8. And then 1/2 squared would be a half times a half. That's 1/4. A half to the first power would just be a half. And then remember, any number that's not 0 raised to the 0 power, right? 1/2 to the 0 power is 1. So look at what happens here. As I decrease the input by 1, every time I decrease the input by 1 unit, the output gets doubled. Times 2, times 2, times 2. So 1/2 to the negative first, well remember, 1/2 to the -1 power is just the reciprocal of a half to the positive 1. A half to the positive 1 is a half, so a half to the -1 would be the reciprocal of that, which would be positive 2. But still positive, right? Not negative. 1/2 to the -2 power would be 4. 1/2 to the -3 power would be 8, and so on. And then if I plot my coordinate plane here, right, I'm going to do, again, a rough sketch of this. Marking off some values on the x-axis and then some values on the y-axis. And let's plot some points that we plotted here. Right? 3 1/8. Well, first I'm going to go 0 1. Right? 0 1 is on this. And you'll notice that that point is on the exponential, any exponential function y equals, just simply a number to the x power. Now, if it's more complicated, this might not be on the graph, right? But on the basic b to the x function, the point 0 1 is on it. And then 1 comma 1/2, right? 1 1/2. Then 2 1/4, half of that, and then 3 1/8. 4 1/16, 5 1/32, 6 1/64. So again, we have this, what's called a horizontal asymptote. The graph, as I move to the right, will go down, 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 but never actually hit the x-axis. Right? Just like in my 2 to the x when I went to the left, right? In this 2 to the x graph, when I went to the left, it goes, keeps decreasing to the left, but never actually hits the x-axis. The same thing's happening here, but to the right. Then -1 comma 2, -2 comma 4, -3 comma 8. Right, and then I'll draw this a rough sketch of the graph in. So once again, as I move to the right, as I increase the input, the value is going down, but never actually becoming 0 or negative. It's always positive. And then if I go to the left, if I plugged in -4, I get 16. Plug in -5, I get 32. So it's going up forever to the left. All right, so once again, we have a horizontal asymptote. All right, a graph that a horizontal line that the graph will, approach but never touch. And that horizontal asymptote is y equals 0, right, the x-axis. All right, now this is they would call this a decreasing function. Right, because as I increase the input, the output's always going down. So this would be considered a decreasing function. And the domain and range are the same. Okay, the domain is all real numbers. Right, in interval notation, that's from -infinity to infinity. Right, I can plug in whatever I want for x. Right, my input could be anything. It's the output. Right, the range that's not all real numbers. Right, the range is only positive numbers again. Right, notice all the y values of these points are positive. There's no y value of 0. There are no negative y values. So the range is from 0 to infinity, but not including 0. And that's the case for any basic exponential function, right? Just a number to the x power. Again, if it gets more complicated looking, the range might change. But the domain for an exponential function is always all real numbers. All right, the domain for an exponential function is always any real number. It's the range that might change depending on how the function is transformed. All right, so what we have here, these two examples, 2 to the x, an increasing exponential function, 1/2 to the x, a decreasing exponential function. That's the way these go are the way any b to the x goes when the base is bigger than 1 or when the base is less than 1. Right, so I will draw this on one more page here. So if the base is bigger than 1, right, if the base is bigger than 1, then the graph of f of x equals just b to the x, right? A very simple basic exponential function looks like this. You're going to have the point 0, 1. Right, you're going to have the point 0, 1. And then b is bigger than 1, so say b is up here, and then 1 over b would be less than 1. There's 1 over b. And you'd have 1b, you'd have negative 1 over b, right, the reciprocal, and it would be an increasing exponential function. And the horizontal asymptote of the x-axis increasing, the domain is all real numbers, the range is only positive numbers. Right? And again, this is just y equals b to the x, simply b to the x. And if the base is less than 1, right, so if the base is between 0 and 1, right, still want positive bases, well then it's just like that 1/2 to the x that I showed you. Right. So b is here, and then 1 over b would be bigger than 1 if b is less than 1. And the points on the graph would be 0, 1, right? Then 1 comma b, negative 1, 1 over b, and it would be a decreasing exponential function. Right? Again, the x-axis would be a horizontal asymptote. As I move to the right, the graph would keep decreasing, but never actually hit the x-axis, and be like that. Right? And all real numbers for the domain, positive numbers for the range. And once again, this is only for the most basic b to the x exponential function. Right? If anything about this changes, then something could change from the graph. Right? All right, so now that I have the generic basic exponential function discussed, let's talk about this number e that they mentioned, the natural base. All right, so here's a special number called e, the number e. Now, all you need to know for this particular assignment is geared toward an intermediate algebra class. So you don't need to know too much about the number e. I know it's a letter, but it's just like pi. Remember, pi is 3.14159 da 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 da. Right? When you see this symbol e, that represents a number. Right? And this is also referred to as the natural base. This number e. All I need you to know is that e is equal to, and it's an irrational number, right? So its decimal goes on forever without ending and without repeating. E is 2.7 1828, 1828, 459045, dot dot dot. All right. Again, this is just what I was, asked to memorize when I was a student, but because this is like Andrew Jackson, and then isosceles right triangle. 1828 is one of the years Andrew Jackson was elected president, and 45, 90, 45 are the angle measures of a isosceles right triangle. But all you need to know is that E is approximately 2.7. Okay, please, if you understand this, if you remember that part, that's good enough for me. All right, but it's definitely bigger than 1. Okay, and this is called the natural base. All right. So when you're looking at the graph of y equals, e to the x power, it'll look like, one of those increasing exponential functions. You'd have 0, 1, and here's 2 and 3, and then e is about here. Right? E is between 2 and 3. It's about 2.7. All right, so closer to 3 than to 2. And then 1 divided by e, you can punch in a calculator. But 1 divided by e would be, a little bit bigger than 1/3. So maybe about here. 1 divided by e, a little bigger than 1/3, but less than 1/2, right? And then inputs, 0, 1, -1, like that. So you'd have these points, 0, e to the 0 would be 1. E to the first would be e, or about 2.7. Right? There's 1 comma e. E to the negative first would be 1 over e, right? Something between 1/3 and 1/2. And once again, it's going to be, because the base is bigger than 1, it's going to be this this increasing exponential function. Now, once again, this is just for the basic y equals e to the x. Right? If any of this changes at all, it might change the way the graph looks. But for the basic y equals e to the x, we have an increasing exponential function. Okay, and again, I'll go to that Desmos site again. We'll put in, y equals e to the x, and I'll show you, right? Y equals e. Now you see, if I just go y equals e, it's a horizontal line, e to the first. And you see 2.7, 1828, 18284. Now it's 46 because they rounded, but it's 459045, blah, 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 right? But again, 2.7. E is about 2.7. And I go y equals e to the x. You see that increasing exponential, basic exponential function that I showed you. Right? Domain is all real numbers. The range is positive numbers, and the base is bigger than 1. Right? It's got the 0.01 on it and all that. And here's 1, 2.718. See 1 comma e, and then -1 comma 0.368. That's between 1/3 and 1/2. That's 1 over e, 0.368. All right. All right. So finally, back to now we're in the assignment. Now I hope you understand what a basic exponential function looks like, and what the number e is, right? This natural base, the thing they call the natural base. Now in this objective, we're just asked to evaluate a function. Just plug in a number and calculate the output. So don't even need to graph anything here. All right. Okay, so we're given this function, which is considered exponential, right? Because the input, the x, is in the exponent. Right? It's e to the x minus, now it's not just e to the x, it's e to the x minus 1 and then plus 2. So the graph of this is going to be a little different than the graph of a basic exponential function, right? If it was just e to the x, I showed you that graph already. But then, replacing x with x minus 1 in the exponent and then adding 2, that moves the graph around a bit. But I'm not going to get in all that right here. All right. all we're asked to do is find what's the value of this function at x equals 3. All right, what's f of 3? So I'm just replacing x with 3. So this will be e to the 3 minus 1 power, then plus 2. All right, so this is e to the second power, e squared, plus 2. And this is it, right? Whatever e squared plus 2 is. But they asked us to round this to 3 decimal places. All right, so I'm going to pull up a calculator. All right, I'm going to pull up a calculator and we'll just enter this. All right, now I got an emulator for a TI-84 Plus right here. Now you could also go to that Desmos website and punch it in there. What's e squared plus 2? And then I just go, second, and then the e is above this ln button. Right, there's e to the second power. There's e squared, and then plus 2 after. Right. So we're getting 9.38905. Now they ask us to round to 3 decimal places. So 9.389, and then the one after that is a 0, so I just keep it the way it is. Now if it was 5 or greater, I'd bump it up, right? Bump it up 1. But 9.389, right? 9.389. And that's all we're asked to do. Just enter the value of 3 into this function and give the approximate output to the nearest thousandth. Great. So let's do that here, right? Just enter 9.389. And that's it. That is all we are asked to do here. Alright, so again, after every question there's an answer explanation, whether you're correct or incorrect. Please read these, okay, whether you're right or wrong. If you're correct, read through it just to make sure that you got it right for the right reasons, that you didn't just guess and get lucky. Or, you might see they do things in an alternate way that you like better and you might want to try in future questions. Now, if you got it wrong, definitely read through the answer explanations so you understand why you got wrong. Hopefully you can figure out what went wrong and learn from your mistakes. Okay, the next question is on the same objective. And yeah, you're just taking some exponential function with a base e. See, it's e raised to the 4x plus 8, right? The input variable is in the exponent, thus the name exponential function. And then you got plus 1 after. And you're just plugging in -3 for x and rounding the output to 3 decimal places. All right. So let me do that here. Okay, so I've just written that function here, and we're asked to find the value of this function when the input is -3. So this is e raised to, and then in the exponent we have 4 times -3 plus 8, right? And I'll simplify that. And then after that we have plus 1. So this is e to the -4th power plus 1. Right? And that is the output. Whatever e to the -4th power is, plus 1 is the output. But we are asked to, again, round this to 3 decimal places. All right, so once again, I'll pull a calculator up and enter, e to the -4th plus 1. So let's clear this. Enter e to the -4 power, then plus 1. And rounding to 3 decimal places, it's 1.018 are the first 3 decimal places, and then the one after that is a 3, which is less than 5, so I keep the 3 decimal places the way they are. The nearest thousandth would be 1.018. Alright, so 1.018, and this is what I'm going to enter in the assignment. So bringing the assignment back, it's approximately 1.018. Okay. And submit. Great. And again, please, these should be quick. You're really just doing calculator work with the number e, which most calculators will have. Next one I do of these, I'll bring up the Desmos website. Alright, so the other one is now, graph. The other objective is graph an exponential function and understand its properties. Well, I already showed you the properties of an exponential function. Right? Again, we're looking at notice we're looking at the basic exponential functions here. Just a number to the x power, some positive number base to the x power. And they're asking us here, which of the following exponential functions is increasing, right, from left to right? Remember, I wrote this up earlier, before the first question. And I'll bring that paper back. All right, let me bring that paper back. That was this here. Right, for y equals, or f of x equals b to the x power. Right. If the base was bigger than 1, you had an increasing function from left to right. If the base was between 0 and 1, you had a decreasing function. So going back to the assignment, so I'm looking at these basic exponential functions. The only ones that'll be increasing from left to right are ones with a base that's bigger than 1. Well, 5.3 to the x, 5.3 is bigger than 1, so that works. 1/5 is less than 1, this will be a decreasing function. 0.71 is less than 1, that'll be decreasing. And 1.8 to the x, 1.8 is bigger than 1, so that will also be an increasing function. Right? Notice they said select all that apply, so I'm doing both of those. And that's it. And you could also put these functions into Desmos, right? Go to Desmos or a graphing calculator and see which ones are increasing and decreasing. All right, and again, read through the answer explanations. All right, next question. This is just the opposite. Now I've already discussed this. Which of the following exponential functions is decreasing from left to right? And once again, we're looking at just basic exponential functions. Y equals some positive number base to the x power only. Right? Well, when that base is less than 1, right? When that base is less than 1, we saw a decreasing exponential function. Right? So not 4.5, not 5.3, 1/10 to the x power. This would be a decreasing from left to right exponential. And same thing with 0.34 to the x. 0.34 is less than 1. So those two functions there would be decreasing exponential functions. Great. And again, you could also graph in some graphing calculator and see that they are indeed decreasing. Alright, okay, another pretty easy one, right? So if you get things about domain and range, just remember the domain is always all real numbers, and the range for these basic exponential functions is all positive numbers only. Right? And the x-axis is called a horizontal asymptote. But yeah, another one where they're asking which of the following exponential functions, basic exponential functions, is increasing. So I'm looking for a base that's greater than 1. So 1.6 to the x and 1.2 to the x. Those are the only ones with a base bigger than 1 to the x power. Those will be increasing from left to right. Okay. And then finally, another increasing one. So it looks like, and based on just the questions I'm seeing here, it looks like they're only asking you about which basic exponential functions are increasing or decreasing from left to right. So increasing again, I'm looking for the a base bigger than 1 to the x power. So 3.2 to the x would be increasing. Y equals 1/5 to the x would be decreasing. 2.2 to the x would be increasing, and 0.12 to the x would be decreasing. So just the ones that I highlighted there, 3.2 to the x and y equals 2.2 to the x. All right, and that should be it for that objective. Pretty simple stuff there. All right, and then the rest of it should just be evaluating functions. All right, just plugging in numbers. So f of x equals e to the x minus 3, and I'm just replacing x with -2. And you know what? I'll just leave this up and pull the calculator up, and we're plugging in e to the x minus 3, and I'm plugging in -2 for x. So I want e to the -2 and then minus 3. And that's -2 and they again ask us to round to 3 decimal places. -2.864, but then the next one's 6, so I bump it up to 865. All right, so -2.865 is what I'll enter here, right? So -2.865 rounded to 3 decimal places. Great. All right, and then finally one more of these, where again I'll just pull the calculator up. So we have e to the 2x minus 1 power and then minus 3, and we're replacing x with 2. Now if you replace x with 2, the exponent would be 2 times 2 minus 1. 4 minus 1 would be e cubed, e to the 3rd power minus 3. All right, so let me pull the calculator up again and go just e to the 3rd minus 3. All right, so e to the 3rd power and then minus 3. Right, and then to 3 decimal places, 17.085, but then the 4th decimal place is a 5 or higher, so I'm going to bump up the 3rd decimal place by 1. So 17.086, right? 17.086. So back in the assignment, f of 2 is approximately 17.086. Okay, and that should be it. So yeah, I know I did a long discussion in the beginning about exponential functions and their graphs, right? Those basic exponential functions and their graphs, but the actual questions themselves should be pretty quick. Right? You're just plugging, for this objective, you're just plugging in a number for x and using a calculator and approximating. And then for the other objective, it seemed like they were only asking, which exponential functions would be increasing or decreasing. So you're looking at the bases, which have a base bigger than 1, which have a base less than 1. So yeah, even though I had a long discussion in the beginning, the questions are pretty quick. All right, and that should be it for this version of this assignment. As I said at the top of the video, right, please understand that the questions I saw here may not be the same questions you see when you do the assignment on your own, but the objectives are the same. The types of questions you see should be similar. The way you would do them would be similar. So I'm hoping that watching me go through these, 8 questions here help you in some way when you're working on the assignment yourself. And thank you very much for watching.